Hi, my big brother, I'm Halloween. In today's video, let's learn about how the I2C protocol works. I2C has two communication lines which are SCL and SDA respectively. SCL stands for serial clock and SDA stands for serial data. SCL and SDA keep a high level by default. Firstly, let's see how to write the data into 24C02. And the start step, data transfer on the bus starts with a start command, which is generated by the active master. A start condition is defined as a high to low transition on the SDA line while the SCL line is held high. After the start condition, SCL starts working driven by the master as well, and the SDA starts sending data. Here, we suppose the device address of 24C02 is 1010001. Send the first 8-bit data from the master to the slave. The left 7-bit is its device address, and the last 0 means writing. The reason for setting the device address is that I2C supports multiple devices working on this bus. Thus, this device address is used to recognize the specific device. One data bit is transmitted with each clock pulse. The transmitted data is only validated when the SDE line data is stable, high or low during the high period of the clock pulse. The high or low state of the data line can only change when the clock pulse is in the low state. Data transmission on the SDE line is always done in bytes, with each byte being 8-bit long. Data is transmitted with the most significant bit MSB first. Each byte transmitted on the data line must be followed by an acknowledge bit AC key. The receiver of the data here is the slave generates an acknowledge signal to indicate that the data byte was received successfully, and the receiver is ready to receive the next data byte. The mechanism to achieve the AC key is that the master releases the SDA line and the slave pulse down the SDA line, since the SDA line remains high level by default. Next, we send the register address to tell the slave where we want to write. We suppose the register address is 00000001. Then the master receives an AC key again. Next, we send the data for writing to the slave. We suppose the value is 10101010. Here, the reason we exactly write 8-bit is the width of 24C02 is 8-bit. Then, the master receives an AC key again. If this is other devices and suppose it has 16-bit or more data that needs to be written, the slave can continuously receive the data until the master signals a stop. Plus, you can also continuously write the data by repeatedly sending data addresses and data. Data transfer on the bus is terminated with a stop command, which is also generated by the active master. A low to high transition on the SDN line, while the SCL line being high is defined as a stop condition. After the stop condition, the bus is again considered free and is in idle state. This is the whole procedure of writing a byte of data into 24C02. Let's continue learning how to read a 1-byte data from the slave. Data transfer on the bus starts with a start command which the active master generates. Send the 7-bit device address plus 1 bit of write. The receiver of the data here is the slave to generate an acknowledge signal to indicate that the data byte was received successfully and the receiver is ready to receive the next data byte. Send an 8-bit register address to the slave. The slave sends an AC key again. The master sends the device address of 24C02 plus 1 byte of read to tell the slave that the master wants to read the data in the previously sent register address. Then the slave sends an AC key and 8-bit data to the master. If it is other devices that have 16 bit or more data to be read, the master will send an IIC key to the slave per 8 bit until receiving the last 8 bit from the slave. When the last 8 bit has been sent from the slave to the master will send an NAC key to the slave. In fact, ACK 0 and NACK 1 are both right. The slave doesn't care about its value. It just needs to leave 1 bit of space. Then the master signals a stop command to tell the slave all the data has been received. This is the whole procedure of reading a byte of data into 24C02. That's all for today's video.